Okay, let's move on. So I've already written the next example out, but I can walk you through it here. So the next example is where they ask you to solve this equation here. X to the fourth equals 9x squared. Okay? So the first thing you have to do is to subtract 9x squared over. Or you could have also subtracted the x to the fourth term over to the other side as well. But I just did the 9x squared term. Okay. So after this step here, we can notice that both of these terms here have an x squared in them, so we could factor it out. So if we factor it out, we have the x squared here, and then factoring out an x squared from x to the fourth, you're left over with an x squared, and then minus 9 because you pulled the x squared out, okay? Just like you did here. So we've factored out an x squared from both terms, but we're not quite done because this term here can be factored into x plus 3 and x minus 3 for the same reason we were able to factor this one here. It's a squared minus b squared, just like this one is a squared minus b squared. Okay? So now we have it that x squared times x plus 3 times x minus 3 is equal to 0. So now we take each of these irreducible factors and we solve them separately. So x squared equals 0. You would then take the square root of both sides. And so, yeah, technically you have to do the plus or minus square root of 0, but 0 isn't really a positive, it's just 0. So there's just one root here. Okay? So then, so this one is, this root here, 0 is kind of a repeat. It's a double root because you have a plus or minus here. So what they call this here is this root, it has a multiplicity of 2 because it's repeated. Okay, so sometimes it might be you might see other multiplicities, but like for all these two roots, x plus 3 equals 0 and x minus 3 equals 0 have multiplicity 1 because they're not repeated. Okay, you can also see the multiplicity of this root here because this is x squared. So if it were just x times x plus 3 times x minus 3, this would have multiplicity 1. Or if this were x cubed instead of x squared times x plus 3 times x minus 3, the 0 root would have multiplicity 3. But we have x squared, so it's multiplicity 2. Okay, so now let's talk about the next type of equations we're going to be able to solve. Okay, so solving rational equations. Okay, so remember we talked about rational equations or expressions in the first chapter, okay, or the review section. So the first thing we need to do is to find the least common denominator between all three of these denominators, okay? So remember, one method to do that is you can just take really any common denominator would work here, but this one does turn out to be the least common denominator. So if we multiply all of the denominators together, so if we write it as 6x times x plus 1, right, that's just 6 times x times the quantity x plus 1. We can use that as our common denominator. Okay, so that's this first step here. So the second step we want to do is multiply both sides of the rational expression by our least common denominator, or a common denominator. Okay. Alright, so if we do that, we're going to take, so it's 6x times x plus 1 times the left side, right? So times 1 over 6 plus 1 over x plus 1 equals, so if I multiply it on the left side, I have to do it on the right too. So 6x times x plus 1 right, times 1 over x. Okay? Okay, so now we're going to do some simplifying here, or distributing. So this, I'm going to distribute this term here to both of these terms. So that's going to be 6x times x plus 1 divided by 6, right? Multiplying by 1, 6 is the same thing as dividing by 6. Plus 6x times x plus 1 over x plus 1, right? Multiplying by 1 over x plus 1 is the same thing as dividing by x plus 1. Okay, so now I've distributed this left-hand side out. I'm going to do the same thing on the right-hand side. 6x times x plus 1 over x. Okay, so now we have some convenient cancellation going on here. So, right, these 6 divided by 6, since we have 6 times x plus 1, we can, those two, 6 over 6 is 1. Also, x plus 1 over x plus 1 is 1, and x over x is 1. Okay, so now this expression now looks like x times x plus 1 plus 6x equals 6 times x plus 1. So now we've kind of taken that rational expression we started with and converted it into something we know how to work with. This is eventually just going to be a quadratic equation, right? So we can factor this, not factoring, factoring is the other way, but this is called distributing. So this is x squared plus x plus 6x. Okay, and then this is 6x plus 6. Okay, so now we're just solving this quadratic equation, and it starts by, again, just moving the terms, all the terms onto one side. So we notice here that if I subtract 6x from both sides, those two just cancel off. Okay, so I'm now also going to subtract 6 from both sides, and you get x squared plus x minus 6 equals 0. Okay, so this one we know how to do because there's a 1 in front of the x squared, so we just need to look for factors here. So two numbers that multiply to -6 but add up to +1. So 1 and 6 is not going to work, but 2 and 3 might work. So if I take x plus 3 and x minus 2, 3 times -2 will give you the 6, and 3 minus 2 gives you the 1x. Okay, so that's the correct factorization. Alright, so our solutions are So the solutions are x equals -3 and x equals 2, right? I just skipped a step where I set them equal to 0 separately, but you would just, for this one, you would get x plus 3 equals 0, and then x equals -3. For this one, you get x minus 2 equals 0, so it's x equals 2. Okay, so there's one difference, though, you have to watch out for when you're doing rational equations. So the book calls these extraneous solutions, okay? And what that is you just have to make sure that your solutions work in the original equation, right? So I'm going to copy down the original equation here. So it was 1 over 6 plus 1 over x plus 1 equals 1 over x. Okay, so what I mean by checking to make sure everything works out okay is, so if I take my first solution and I plug it in here, x equals -3. So that gives me 1 over 6 plus 1 over -3 plus 1 equals 1 over -3. Okay, so that actually works out because we're not dividing by 0 here. That's what you really got to watch out for, right? So it turns out that if you do the x equals 2, it works out again because neither of the denominators were 0. Okay, so it turns out that both of these solutions are not extraneous, or they work. Okay, so we'll see in the next example a solution that actually will cause you to divide by 0 in the original equation. Okay, so let's just get right to that example here. So in this one, they want you to solve x over x minus 1 minus 1 over x plus 1 equals 2x divided by x squared minus 1. Okay, so here we can find a least common denominator, right? That's the first step. So find LCD. And it's not just these two on the left-hand side, but it's also, you want to not forget about this right-hand side too. So when you're finding a least common denominator, it's sometimes best to factor completely, right? So here we have an a squared minus b squared. So I'm going to rewrite this equation here real quick. X over x minus 1 minus 1 over x plus 1 equals 2x, and the only thing I'm changing here is I'm just factoring that denominator here. So a squared minus b squared, so that's the same as a plus b and a minus b. Right, so b would be 1, because 1 squared is still 1. Okay, so now we see that actually our least common denominator is just this guy right here, because if we multiplied this fraction by x minus 1 on top and bottom, and then this fraction by x plus 1 on the top and bottom, we'd have the same denominator on all three. Okay, so the LCD, or the least common denominator, is x minus 1 times x plus 1. Right, in the last example, there was no other option but to just multiply the denominators together. But in this case, we could have done that and got a just common denominator. But then our common denominator would have an extra term here. So it's always best to try and find the least common denominator first. Okay. So now that we've done that, our second step is to multiply both sides by the least common denominator. Okay, so if we do that, we get right, so x plus 1, x minus 1 times x over x minus 1. Oh gosh, sorry. There we go. Right? Minus 1 over x plus 1 equals 2x over x plus 1, x minus 1. If I multiply it on this side, I have to multiply it on the other side too. Right. Okay, so again, we're going to get some convenient cancellation here, right? So I'm going to distribute these two terms first. So we get x times x plus 1, x minus 1, right? We can think of this as multiplying two fractions together. Just think of this denominator as 1, right? You multiply the numerators together, x times x plus 1, x minus 1, and you multiply the denominators together. Okay, so that's the first term. So then we would have x plus 1, x minus 1 over x plus 1. Okay, so here we've got some nice cancellation that goes on, right? These two all cancel out, and you just get a 2x on the other side. Okay, we also will cancel x minus 1, x minus 1, x plus 1, x plus 1 here. So now we get x times x plus 1 minus x minus 1 equals 2x. You got to be careful about this minus sign. Keep the parentheses around just so you don't mess that up, right? So now, if we simplify this here, we get an x squared plus x minus x, and then a minus and minus makes a plus. So it's x squared plus x minus x plus 1 equals 2x. So these two, if you add the number and then subtract, that drops off. So it's x squared, and then I'm going to subtract 2x from both sides. X squared minus 2x plus 1 is 0. Okay, so now again we've taken this original rational equation here, and we put it into a form that we know how to solve, a quadratic equation, right? So now we have to look for two numbers that multiply to positive 1 but yet add up to negative 2. Okay, so this is actually going to be another one of those repeated roots, right? So it's just x minus 1 times x minus 1, or x minus 1 squared equals 0. So this root, right, x equals positive 1 by adding 1 on both sides, it has multiplicity 2, okay? Okay, so once you have, so I guess I should maybe write step 3 here. So we have step 3, solve. Okay, so now once we've solved, we can check roots to find, see how is this spelled? EXTRAN. Okay, so we did this in the last example, but I didn't write out the step. So check your roots to find extraneous roots. Okay, so the root that we have to check is x plus 1. So again, we're going to take that and put that into the original expression or equation. So it was x over x bear with me. So x over x minus 1 minus 1 over x plus 1 equals 2x over x squared minus 1. Okay, so now the problem is if we do x equals 1 here, we get 1 over 1 minus 1, that's not good, minus 1 over 1 plus 1, this one's okay, equals 2x over 1 squared minus 1. So another problem. So here, in both of these terms, we're dividing by 0, and that's a no-no. Okay, so it turns out that this solution, x equals 1, is an extraneous root, and so you actually have no solutions. Whoopsies. Okay. Right. Okay. Alright, so now we can move on to the next topic of this chapter. Okay. So this next topic is equations. Equations involving radicals. Okay. So the first equation that we're going to talk about, or the first example, is solve x equals the square root of 6x minus x cubed. Okay. So the first thing you want to do is you want to figure out what power you need to raise both sides here to get rid of the radical. Okay, so to get rid of a radical, you want to, or to get rid of a square root, you want to take both sides and square both sides. Okay. So this side, if we do that, it's going to be x squared. Sorry. X squared equals the square root of 6x minus x cubed squared. Okay, so this really, you can cancel out the square in the radical here and get x squared equals 6x minus x cubed. Okay, so now this is again looking like something we've already solved before. So let's, this is just it's not a quadratic equation, but it's close. It's an order 3 equation, but we know how to solve some of these. So let's do our usual method here. I'm going to add x cubed and minus 6x to both sides. Okay, so now I get x cubed plus x squared minus 6x is equal to 0. Okay, so now it just comes down to factoring this equation here. Okay, so the next thing is you notice that all three of these terms have an x in them, so we can factor that out. X times x squared plus x minus 6 equals 0. Okay, so this term is done, but we need to factor this one. So again, it's actually the same thing we saw in the other example. It's adding up to positive 1, but multiplying to negative 6. So this is x times x plus 3 and x minus 2 equals 0. Okay, so we solve each of these separately. We get x equals 0, x plus 3 equals 0, and x minus 2 equals 0. Alright, so this one's done. Can't do anything about that. This one you would subtract 3 from both sides, so you get x is negative 3. And this one you add 2 to both sides, so you get x is positive 2. Okay, so those are the solutions to the equations, but we need to check them. Okay, so if we talk in the original equation, so let's see. So negative 3. Let's do negative 3 first. Negative 3 equals the square root of 6 times negative 3 minus negative 3 cubed. Okay, so negative 3 equals, so this is a negative 18, and then, so minus 3 cubed is actually negative 27. Okay, so negative 3 equals the square root of negative 18, so minus minus is plus 27. Okay, so this is negative 3 is equal to the square root of 9. So this one doesn't work because this is saying that negative 3 is equal to 3, and that's not true. Okay. So notice it's not, when we take the square root, we always do that plus or minus thing here, but this is actually already telling you to take the positive square root, right? This has a little invisible plus on it, right? So that's why this is a positive 3. Oh, and you guys didn't even see all that. Okay, so we've got, here, let me go through again. So negative 3 equal to 6 times negative 3 minus negative 3 cubed. It's plugging our one root back into the equation. So negative 3 is negative 18 minus minus negative 27, right? That's negative 3 cubed. Negative 3 is equal to negative 18 plus 27. Negative 18 plus 27 is 9. And then, again, I was saying they're already telling you to take the positive square root when they don't write plus or minus out front. You're just assuming plus. So this one now comes down to negative 3 is equal to 3, which is not true. So negative 3 is not a solution. Okay, so it turns out if you check x equals 0, you get 0 is equal to 6 times 0 minus 0 cubed. So this one says 0 equals 0. That's checking out. Okay, let's try x equals 2. So 2 is equal to the square root of 6 times 2 minus 2 cubed. Okay, so 2 is equal to the square root of 12 minus 8. 2 is equal to the square root of 4, so 2 is equal to 2. That checks. So the solutions are 0 and 2. Okay, because negative 3 was eliminated.